In this video, we are going to discuss how to solve absolute value equations algebraically, but we're also going to work to check our solutions graphically, just to be sure that we can visually understand what's happening when we are solving. So, step one is always going to be to isolate your absolute value. Okay, that means we don't care what's inside the absolute value bars. We just need to work to get those absolute value bars to be by themselves on one side of the equation. Then we are going to write two equations, removing your absolute value bars. Then we are going to solve both equations. So for this first one, just like when we solve a one or two step equation, we want to get the x by itself. Here we want to get the absolute value by itself. So we're going to add 4 to both sides. We get 9 equals the absolute value of x. Then we are going to write two equations and drop our absolute value bars. When I say two equations, we are going to say x equals 9 and x equals negative 9. So we want the value that we see and the opposite of the value that we see. In this case, our two solutions are 9 and negative 9. If I were to have graphed the absolute value function, absolute value of x minus 4, my vertex would have been at 0, negative 4, and my slope would have been 1 to the right-hand side, and then negative 1, or up 1 and left 1, to the left-hand side. If we wanted to see where this absolute value function does indeed cross a y value of 5, we would plot a y value of 5, and we would draw a horizontal line and see that our horizontal line does indeed cross the absolute value function at 9 and negative 9. Okay, next example. We want to isolate the absolute value bars. Again, we don't care what's inside the absolute value bars, we're just isolating them. So we're going to add 3 to get 6 equals the absolute value of x plus 2. Once you've gotten the absolute value bars by itself, you are going to write two equations. We're going to write 6 equals x plus 2, and then whatever the opposite of this value is, negative 6 equals x plus 2, and solve both equations. So to solve this one, I would subtract 2, I get 4, and then here I would subtract 2 and get negative 8. You want to be really mindful that you do not fall into the assumption that if you get one answer, it automatically matches and is the opposite, because this is not the case. Okay, if I were to graph the absolute value, we were graphing the absolute value of x plus 2 minus 3. So my vertex would be at negative 2, negative 3. My slope would be up 1, right 1 to one side. And then up 1, left 1 to the other side. And then if we were to have graphed the value that we were looking for, y equals 3, it would be a horizontal line through here. And we can see that this horizontal line crosses the absolute value function at negative 8 and positive 4. Okay, we'll solve one more. We get the absolute value by itself first. So we don't want anything on this side of the equation besides the absolute value bars. So I'm going to subtract 4. We want to get the absolute value by itself. So if we have 3 out in front, we want to divide by 3. You cannot distribute a 3 into the absolute value. You have to keep the 3 on the outside and divide it. And now that we're at the point where we just have absolute value on one side, a number on the other, we can write our two equations. We can say 2 equals x plus 1 and negative 2 equals x plus 1. To solve these, we would get x is 1 and x is negative 3. Again, if we would have looked at our beginning function here, and we would have graphed, the vertex was at negative 1, 4, and our slope branches were 3, so up 3, right 1, or up 3 and left 1. Okay, so when we go to graph, where does this absolute value equation equal 10? We'd graph a horizontal line at 10, and the x values would be 1 and negative 3, which are the values that we originally got. If you need any reminders of graphing, we have a video for that, so how to graph the absolute value functions. If you need reminders of characteristics of the absolute value functions, we can also have that video as well.